Good evening. Welcome to day one of our bootcamp. I'm going to talk a little bit about the dynamic experience delivery, content delivery platform, and the changes that we've introduced that come along with the upcoming Tridion Docs 15 release. I'm going to cover three areas today. First up will be around what we call semantic content models. Then I'll talk a little bit about the improvements we've made in our semantic AI feature, and in particular, the recommendations feature that we've introduced. And then finally, I'll talk a little bit about some platform improvements, focusing on some performance improvements we've made to our platform. So, semantic content modeling. So, a brief history of our dynamic experience delivery with the Docs platform, and in particular, what we call our public content API. Now, this API was introduced with DXD11, which came with Docs 13 SP2. This provided a GraphQL-based API that exposed a number of new ways of retrieving content from our platform that superseded our legacy OData-based REST endpoints. Now, GraphQL provides a series of root queries. You can think of it a little bit like a query language that allows you to build different types of queries to retrieve the content that you want, rather than a sort of typical REST API where you're asking for specific content and always getting back the same content with your REST requests. So over these various versions, we started off with a core API that supported our delivery platform, and then we began to introduce new APIs to support new features. So you can see on this timeline here, the sort of the key APIs that were introduced at various points. The interesting ones for the Docs customers, I think, was around the search API in DXD 11.5, because this is where we provided a search interface on top of GraphQL that sort of unlocked a lot of our semantic AI features going forward. And you can see in the last release of Docs and DXD, we included that faceted search API. But at the same time, we also included this semantic content modeling for Tridion sites. Now, this didn't help Docs customers, so we still have terminology in the current 11.6 release that's kind of unfamiliar to a Docs user. So that's what the purpose of the semantic content modeling in Docs aims to address. So just as an example, this was a typical GraphQL query to get content out of Docs from our content service using GraphQL. And as you can see in the example here, we're talking about pages, not topics. We're talking about namespaces, which, again, what does that mean to a Docs customer? We're talking about component presentations, which very much is a site's concept, and various other bits in here that don't really kind of lead neatly to how a user of this API would want to get that content. And more importantly, the actual results that come out, you can see this property here on the request in GraphQL coming out here. It comes back as one big chunk of JSON, and within it there's a whole bunch of stuff. And the actual interesting bit that you're interested as a Docs customer is buried down in this topic body property here. But none of this you can get to directly. You just get this big chunk back, and you have to parse it yourself. So the goal really was to make it much easier for users to interact with our content API using familiar terms for Docs customers. So this is an example of such a query that we've introduced in the new DXD 12 release coming with Docs 15. So you can see we've introduced some new root queries that are specific to Docs concepts. We've kept the ish prefix for consistency reasons, because I think most Docs customers are still familiar with that. And then you can see within that there's some terminology that is more aligned to what a user of Docs would be more familiar with. So within that GraphQL query, we've provided these 5 new root queries. Obviously, we've got the basic stuff, so getting a publication or a list of publications. And then we have facilities for retrieving single topics, multiple topics. And finally, the ish table of content, which is obviously used for building site trees and navigation devices. And then to support that, we also have provided a number of ways of seeing the results of those queries in terms of a number of topic types. So obviously in DITA, you can define custom ones, and there's a number of standard ones that we support out the box as well. So you can see this list here. We've included these in this current release. And I'll talk through a few of these in our examples coming up. The generic one here is to support those cases where a customer has had their own sort of definitions defined or customized it, but it still allows you to interrogate and dig out the various sections within those topics. So just going back briefly to the challenges we had in the previous architecture, I talked about the content that you get back out of the content service, which was this green service here. But the challenge is, of course, this piece on the right here. So you needed this dynamic delivery web application, which was a module that ran within inside DXA, which was our digital experience accelerator. That included all the libraries to talk to the service, but also included all the mechanism to decode that that chunk of data that we talked about. So essentially, it made it a little bit complicated for customers wanting to customize this. So we provided an out-of-the-box solution that worked quite well for a lot of customers. It did have a React web app sitting in front, but it still required all this kind of plumbing here. So the benefit to the new release is that we now focus on just that pure GraphQL headless endpoint in terms of retrieving your content, and allowing you to interrogate the data you need more easily in a lightweight web application, or even a client-based web application if you so wish. The one thing worth noting on this diagram that we added, and this came in our own cloud services, was this component called the API gateway. Now, the reason this was important is because if you have headless APIs, such as our content API, you don't particularly want the internet having direct access to it, because it opens up a range of sort of security and denial of service challenges and those kind of things. So we introduced this idea of a content gateway that we deploy in our cloud services. It provides these features here. So it provides authentication and provides its own session token handling to any applications that talk to it, which then hides all the authentication onto our own services from the web, because you don't really want to be publishing them to all and sundry. And it provides a number of other features as well, including things like rate limiting, logging, a web application firewall, and metrics and security. So this really just is a layer that intercepts GraphQL requests coming through our cloud deployments, and then sits in front of our content service and allows us to better handle requests coming in. And this is the thing that really is the key to unlocking customers that want to build applications against our headless content service. Another option is, of course, that the customer continues to build a web application talking directly to our content service that they have control of. So that provides that same layer of abstraction to prevent those challenges that we just talked about. But this is all now something that we'll be offering in the 12th release. The API gateway was actually available in previous releases, but for the semantic content modeling piece, which simplifies building these clients, this is where it will really come into its own. Let me just jump across to a quick demo on this one. So we'll start off with how we've set this up within Semantic AI and within structured content, within organized space. So we have in our sample here, we have a sample publication with a number of topics here. It's one you might be familiar with the phones in there. And clearly these have, within these things, they have a lot of topic content that is structured in a way that's sort of familiar in the docs world. Just switch across here. So I'm using a GraphQL client here called Insomnia. There's many open source and free GraphQL clients you can use. It's very useful for developing against GraphQL API because it provides introspection, documentation, and those kind of things. A really simple query here, you can see, talking to our endpoint. This is an existing query that we provide. Just to give you an example of how these introspection works, you can see the documentation here, and you can drill down and see all the various types and features within here. So it's really just a recommendation on anyone building against our GraphQL endpoint to use a tool like this for developing, because it's much easier than trying to use Postman or trying to work it out just from documentation. It's much easier to explore using one of these things. So let's go back to our semantic content model sample. So this was the old way we talked about. So again, you can see that raw data chunk here, which is all of that piece in there, comes back in one big chunk of JSON. And the actual content we're interested in is this piece in here, which is our XHTML that we retrieve from Tridion docs. So it did, the old way fully supported things like conditions, so you could pass in conditions in this kind of slightly convoluted manner here, using this user conditions merge thing. But again, this was all due to the baggage of that dynamic delivery web application. So jumping straight forward to the new queries, here's our topic query. You can see here we have the option to provide conditions in a more sort of meaningful manner. You can add any additional conditions to this list, add values to it, and they get combined with any conditions that the publication has attached to it as well. Interestingly, you can see the use conditions as well in the results down here. So this shows that this particular topic that's coming back uses this condition in there. So we started to expose some of the features that are kind of useful to docs customers. So here I'm showing you the chunk of body XHTML, but again, this isn't probably how you would want to use it in practice. You're probably more likely to use some of these facilities here and actually drill down onto specific types. So in this example here, we're looking at, in the type here, you can see this is coming back as an ish task topic. You can see that using this type name thing, it's useful for interrogating results coming back. And the nice thing with GraphQL is you can then, handle those different types in different ways. So in this case, we're saying, if you encounter one of these task topics, expose these particular properties. So again, this is very geared up for, in this case, you can see the actual sections within that body piece rather than that big chunk up here. You can see it's actually parsed that out. And it's bringing it right down to just the content you're after. So the nice thing about this is if you're building a web application, you don't have to handle all that parsing yourself. You can just say, give me this particular section. You can get it back and you can use that then within your web app to render the bit that you need. So again, each of these things as well has a type as well, and you can further drill down if these things have any specializations. I talked before about the generic and the specific types of things within the content. So you can see an example here of one. So we've provided a standard sort of steps option down here, which is this one here. There's a step, this procedure here is one of the steps there. Or you can also get it back using the sort of more generic sections mechanism here. So typically you wouldn't use this and this together. This is just a demonstration of the flexibility of this new query, that you can really get the detail that you want specifically. We handle links independently as well. So you can see here that we can get back all the links within a topic, and this will get everything back, including if you want binary details. In this example here, it gives you links to binaries within there. And again, we provide further sort of specialist queries to get more specific pieces back. So in this case, we have a related links feature here, which will give you just the related links from that list, which is demonstrated here. And then as you drill down on these things, you know, this was coming back as a ish generic topic. You can then choose to further drill down. And this is the nice feature of GraphQL. You can keep drilling down at each level and further get back the detail you want. So we've now actually drilled down additional level to get the content from the related links themselves. So the neat thing about this is you could build a request, particularly for rendering a home page, you can imagine, where you might want to see perhaps the sort of the abstract or something on that home page, but without the full chunk of it. So you could drill down maybe just a short description and the title or something like that, and use that to render your page. But you can do that all in one GraphQL query rather than multiple queries for all those kind of things. So hopefully that gives you a flavor of the kind of things you can do with this new query. It's very much geared up for docs topics and the related pieces. We support the topics query as well. This one obviously allows you to filter on various properties here. So in this case, we can pass in a list of publication IDs and it will return the various bits, the topics that come back. And again, if you put the type name in there, you'll see the type coming back. And you can, you know, if you've got task topics, generic topics. So for each of these, you could choose to do, you know, on concept topic and further get information about that. That will actually give us anything. Okay, that one's not defined on that one. But you can see the idea here. You can further drill down and support these things. So this might be a useful one if you're building up a homepage menu of publications, for instance, and you want to pull back certain pieces, and you could pull back images and things from those topics as well. Ish publications plural, they're fairly self-explanatory. I've included the custom metas on here, so if you want to get back specific custom meta, you can drill down, and obviously this is related to the custom meta that have been defined within your docs data model. You can get all that data back there. And similarly for publications, this gives you a list of publications that are published to your DXD platform, which in this case is just that single one. And then finally is the TOC query that we've introduced. So this allows you to build up that navigation structure, whether it's a table of contents or a sort of a walking drill down of each level. So you can choose to keep drilling down multiple levels at each level. So I could put in another one of these here, and that would get you a third level down. Which is one way of retrieving that content. I should add that we've actually recently done a fix for one of our customers that's actually optimized this, that allows you to specify a depth in one query. So rather than having to build up multiple depths, you can just say, give me a depth of 3, and it brings it all back. So we will include that in the final release of this ishtalk, that will include that sort of optimized query as well. Because this works well for when you're kind of stepping down a tree, but if you want to pull back an entire sitemap, and if maybe you have thousands of topics in there, it might be a bit slow if you've got lots of depths, because each time it's having to recurse and do a new query on the database. So that's why I introduced that other query. Okay, let me return to presentation a moment. I'm going to hand over to Evo to talk about 3 pieces of this that are relevant to CM publishing.
Hey, thanks, man. Indeed, so if you publish indeed our Tridion docs content to DXD, it also ends up in a particular URL structure. It consists of the hostname, publication ID, and topic ID. Basically, the topic ID is actually the language card ID, and that of course will change between versions. So if you, for example, create a piece of documentation about your printer, and you see there's a mistake in there, you want to update it or make it even better. And if you publish it again, then of course it gets basically a new topic ID. So if people actually bookmark the URL, they never see the new content. So how can we actually fix that? But also you have to think about if you publish something and you change something in your baseline indeed of for the fallback language, and suddenly you have indeed the correct language translated, then of course the topic ID will change as well. And then, yeah, like I said, if you bookmark it, you never will find it. So how did we actually fix it and come up with a solution? So instead of using the language card identifier, we also now have the option to also use the logical object identifier. That's also like a card ID, but then from the logical level. So that one always remains the same of the whole object itself, basically. So in that sense, the URL is the same, but then you can actually see the updated content. And so the out-of-the-box configuration, we actually set now on the content object level. That's now actually set to logical. So that's also the new out-of-the-box experience. If that parameter isn't specified, we'll actually use the language card ID. So that is the current implementation. And indeed, so the options that you can actually set are actually logical or language level. So that is one of the fixes or the improvements that we make for DXD. There are also something about if you make a conref to another kind of topic. So if you then publish your publications that conref to another topic, that topic was also published as well. So if you then do a search, you can actually find that particular topic. That sometimes it's not that you want to find topics like that. Because yeah, but they live on their own. You don't see them in a table of contents, but you can still search them as well. So now we actually don't publish them anymore. Indeed, so that is also the second thing we improved basically on publishing our Tridion docs content to DXD.
That's great. Thanks, Eva.
Okay.
So next up, we're going to talk about our recommendations feature, which is an extension to our Semantic AI. So if you're familiar with the faceted search from the previous release, we introduced a range of search capabilities to the content service based upon the taxonomy space, which is supported by the pool party taxonomy engine. And we're kind of harnessing some of the facilities that we've built already to provide a recommendations engine there. So what are content recommendations? Essentially, it's asking the question, show me other content like this, or find me related content. And the way we do that within Tridion is we use the fact that we have reliable tagging on our content, and that's very important in this world of generative AI, where a lot of content is, sort of relations are based on the language models applied to content. In our case, we want the reliability of a content editor or a knowledge manager who's had given that sort of seal of approval, if you like, on the content, saying, yes, this content has this particular tag associated with it. So we're leaning on those concept tags that we've already applied as part of that whole faceted search tagging piece that we talked about in the previous release, and then kind of harnessing that feature to find that recommended content based upon that taxonomy. So in order to do that, what we did, we extended our existing content search API, and it allows you to include a new recommendation parameter That parameter can take a number of options. So you can give it an existing document or existing topic, for instance, and it will work out the footprint, which is essentially which tags are associated with that topic. And then it will use that footprint to determine other content based on term frequency matching on other documents that have that same or similar footprint. But again, based upon those tags applied to that content. So this will only work on tagged content. It won't work on content that hasn't been tagged. And that's why we're using the whole taxonomy space with Pool Party backing that up. So you can use multiple concept schemes, which is essentially the fields, if you like, that you map within Tridion docs to a particular facet, if you like. You can boost individual weights on each of those schemes, and I'll talk a little bit about that in the demo. We also allow you to provide full filtering of the results using all our existing search criteria. So the way recommendations works is it gives you, a number of results ordered by score, and then you can then filter those results, whether that be by publication, or namespace. If you happen to have a sites in the docs system running together, you can get both back in your results as well if you wish. And it also unlocks the ability to combine our semantic content modeling as well, because we expose that through the broker part of our search query. So here's a small example here of how it works. So you can see this is the recommendation piece that we add to it. In this case, we're giving it an existing document. We're passing in the name of the connector, which maps onto the concept scheme within Pool Party in the field that you have mapped within docs. And this example, we're doing a boost by, and I'll talk a little bit about that in a minute. And then the results, that's the same results that we had in the previous search. That hasn't really changed. You can see a small example here of how that looks. Just a quick run through of how it's wired up underneath. I'm not going to go into too much detail here, but suffice to say that we, in this recommendations piece, are just using this part of the architecture to work this out. So, we've already populated our open search index, and I'll talk about that later as well, with the concepts that we have within taxonomy space coming from Pool Party, and B, the content and the tags against those content, that all sits within this open search index. So this is what allows us to provide recommendations purely based on this index. So our recommendations only works against this index. It doesn't need access to this beyond that time you've done publishing your publication to the dynamic experience delivery platform. And then it opens up all these various search features. So the first 5 of these were already provided by the previous search capability, and we've added recommendations to this. So I'll do a quick demo on this. So this is the taxonomy that we have set up in Pool Party. I'll show you these examples because these are the ones I've chosen to use for today's demo. So this is a particular facet that we have hooked up that sits within our topic. So if you look at your fields on the bottom of this, you can see we've started tagging these topics with some concepts. You can see we've got ones there. We have another taxonomy wired up as well. So you can obviously have multiple concepts mapped to your fields within Tridion docs. These can contain multiple tags if you wish. So if we then jump back over to our GraphQL client, I can show you how those queries would look. So first, just to demonstrate that we have that taxonomy within our open search index in this case. So when we publish to DXD, we do two things. Firstly, we populate our search index with the content and the tags associated with that content, and that's done by concept ID. So it's all referenced by ID. And the second thing we do, we populate another index called the concept index, and this is essentially a mirror of the taxonomy structure that is stored within taxonomy space coming from pool party. So this taxonomy, you can see I've drilled down one level here. You could, much like any other GraphQL query, you can continue to drill down, but you can see I've got the whole taxonomy sitting in here. And that's important for our broaden query, which I'll talk about in a minute. But simple search, this is just regular search, no recommendations in here at all. So in this case, we're just searching for all the content that sits within the docs namespace in the search index. And this comes back in this case with some pages coming out of the topics within the index. So if we then go on to the recommendation query, so this sample here, I'm passing in an existing ID. So in this case, I think it was the that first one I showed in the example, which had a usability concept associated with it. Then when you do a search with it, I'm also filtering. I was talking about the filter earlier, so this is adding a filter saying just give me back docs results in this because I'm not interested in Tridion sites results from this. You can see I'm getting back all the hits. You can constrain this so you can do pagination in a more controlled manner. You can see there's 22 results coming back. You can see the score being returned here. And this is the most important thing, I guess, because this is how the search ending is determining how closely matching these results are to the supplied footprint, if you like. And then again, you can drill down and get some further information about these results as you go down. So each of these nodes is a search result. But you can see if we're coming back here, we're doing a simple search. It's obviously finding things with usability on those tags. So it's just looking at that usability piece in this case. But what if you want to boost those queries? So the concept of boosting is useful when you have multiple facets. So let's say, for instance, you have one facet that might be categorizing your concepts, your content based on a task type, for instance, which is what these examples were. And then perhaps you've got another facet based upon industry or something like that, some completely different facet. You still want to be able to get recommendations back, but you may say that you want to include multiple facets within your recommendation calculation, but you might say that this particular facet is more important than another one. So this boost by parameter just allows you to boost those scores essentially for those particular facets. So you can see in this case, I'm only using one facet in this example because I haven't actually got another one wired up on this sample. But in this case, you can see the score that was 0.92 before is being boosted by 100. So you can use that to begin to sort of tailor your recommendations for particularly use cases, and it allows you to build up a more focused recommendation query for end users to use on their site. And again, in this case, we're still using the existing document to determine the starting footprint. You can also specify specific IDs as well. So this isn't providing a footprint of an existing document. This is just saying, look, I know that I want to use these specific concepts to drive the recommendation. So you can put in a list of IDs on this if you wish. You can add in multiple facets, again, multiple connectors. Each one of them can be either broadened or boosted. And the broaden by is an interesting one. So I talked earlier about having access to that taxonomy query, what broaden by does essentially allows you to walk back up the taxonomy tree and look at related content sitting at the level above and then below each of them. So broaden by one will walk back up one level in the tree. So in this example, you should continue to see the usability things, which will obviously be the highest rating ones. And then when it runs out finding ones at that level, in this case, you can see it's moved up the level here and has found this concept called entertainment, which is one level up, if you remember that taxonomy I showed you at the beginning, and it returns them as well. You can see the score is considerably smaller than those at the the single level. So you can begin to see how the different levels of the taxonomy plays a part when you're using these recommendations. And again, allows you to tune your queries based upon your understanding of your semantic content model. So that's the recommendation query. As I say, that's all provided on top of this existing search thing, and you can use all the facilities of criteria here. You can also include facets on here. So if you remember from Docs 14 and DXD 11.6, you provide the option to actually show you document summaries, which are facets. So you can include the facets in the results as well if you wish. So not only you could do a recommendation, but you could get those matching results and the facets that match those results themselves. Okay. Let me jump back to my presentation. So performance improvements. So DXD 12 had a number of technology updates that we applied to the platform, but chief amongst them was our cache layer. So we did have a cache in the product. It'd been in the product for a while. It was sort of handcrafted memory management solution, and it was pretty hard work to monitor and debug if ever there were issues with the cache. And it did create a number of hotfixes back in 2021. So that kind of drove the need to think about how caching worked in our product, and was it worth investing in an improvement at that point. And then obviously with the introduction of the Tridion docs information architecture, where you might have quite large publications with large numbers of topics, it kind of drove the idea of rethinking perhaps how we manage the cache. I mean, in particular, the way we invalidate entries, perhaps getting rid of some of the complexity that we had in the end, and finding ways of improving scaling as well, because the previous cache was all in process within individual services, and it relied very much upon the memory footprint of that service serving the needs of the cache, but no way of actually scaling that out across other services. So this is why we came up with this new cache mechanism. So most important for us was that it was standards based. So that allows us to, at some future stage, we could choose to rewire this onto some other cache implementation. But for our release, we chose Apache Ignite, which is a open source Apache 2 licensed cache framework, amongst other things. It's also a data store, but it's often used as an in-memory or a persistent cache. The cache design itself was simplified significantly, so we wanted to get rid of all the complicated dependency check mechanisms. So we switched to a sort of timestamp based design, which is much easier to implement and debug as well and maintain in case we ever want to add new cache regions to the system. And because this is using, in this case, Ignite, it gives us a whole bunch of flexible deployment mechanisms. So out the box, we will continue to provide it embedded within the services. And I can show in a minute how that will look. But we also wanted the option to have it either replicated or partitioned, and maybe at a future stage distributed amongst a standalone node as well, if necessary. But this is how we ship it in DXD 12 today. So you can see we have this new caching layer that sits within both our deployer and our content service. We used to use a JMS queue to do invalidation messages from the deployer, from the deployers, plural, to our content services. But that was yet another component that we had to maintain and manage and caused some issues for some of our customers. So the nice thing about using this particular implementation is that Apache Ignite can handle its own invalidation just by essentially creating a cluster across all of these services. So the way we deploy this is each of these services has an in-process Apache Ignite node. They all talk to each other through a cluster. The clusters register themselves actually within the broker database, so they can find each other without having to do any special configuration. You just point Ignite to our database, and when they start up, they will register themselves in there, and then they will add themselves to their own cluster. So you can add content services on the fly. Those Ignite instances will add themselves to that cluster on the fly, and then they will extend themselves. So the real key thing here is the fact that we have this replicated cache across content. And that means that we can scale up the content services nicely. And it also means that because it's replicated between the nodes, you don't have the overhead of warming up the cache whenever you have to recycle your content service, because Ignite's really fast at pulling data from one of its nodes to the other. And then that is available straight away for any. That's our cache piece. Finally, just a slide on a platform update. So these broadly align with the Tridion Docs 15 platform support. The key one that's different, I guess, is our use of OpenSearch in the platform, which wasn't something that's part of the DocCM piece, of course. And it's also worth noting that we've switched from Elasticsearch to OpenSearch. Now, this was driven by the changes in license that Elastic forced upon the community a couple of years ago, which created a bit of an uproar. It wasn't very compatible with the way we deploy our customers, because it creates a legal grey area about whether our service is providing search facilities or, significant search facilities, and it just became complex to deploy. So we chose to use OpenSearch, which was forked from Elasticsearch for this very reason. It's an Apache 2 license fork. It's supported partly by the AWS community, but also by the open source community. It fits quite neatly in our old cloud deployment, because AWS obviously provide a managed OpenSearch service, so it simplifies, continues to maintain that sort of ease of management within our own cloud. And it also has some extra features beyond Elasticsearch. So it has a lot of security features that are out of the box that you would normally have to pay Elastic for. And there's some fun machine learning things that might unlock some future features, but you never know. So out of the box, we support the latest OpenSearch 2.x release. All two releases are broadly compatible according to OpenSearch, which is why we chose to use an X release here. They do update every 2 months or so, so they've got quite an aggressive update timeline on those releases. And in terms of upgrading, it's a fairly straightforward process for customers. If they have an on-premise installation already, they obviously need to have that Elasticsearch cluster running. They will need to create a new OpenSearch 2 cluster. And then we provide a PowerShell migration script. You basically point it at your 2 endpoints. It goes ahead, recreates your indexes for you, and then you can test and deploy it against the DXT12 setup. So it's fairly straightforward to do that process. Obviously, customers do need the bandwidth to create 2 search clusters. So if you have a large Elasticsearch cluster, they'll need enough space to have another cluster for the duration of the upgrade. And then finally, as I said, the platform support pieces themselves are broadly in line with the Docs, Tridion Docs platform support pieces here. So we've got support for some out of support platforms that are generally not supported by the vendors anymore. And we've moved forward to these later releases. It's worth noting on the JDK 17 piece, as part of our platform updates, we also upgraded to the latest LTS Spring release as well, which is 5.3. It's not Spring 6, which some customers have asked for, which is still a sort of a non-LTS release at the moment. That's it. Thank you very much, and enjoy the rest of the bootcamp.